So in this class, we are going to discuss about if a sequential circuit is given to you, how to find out or how to extract the state diagram from it. So how the question will come up mainly? The question will come up in this way: derive the transition table and state table, transition table, comma state table, and state diagram for the Murray sequential circuit given below. Okay, so do you all understand the question? What you have to do? You have to find out the transition table, state table, and the state diagram for the given Murray sequential circuit. Okay, so how the circuit is, I am just doing here. Just see here. So this is my JA, KA, A bar, and this is flip flop A. This is my JB, KB, B bar, flip flop B. Okay. This is my F, and there will be clock pulse. So this is my clock pulse. Next, there will be input X. It has X bar. Okay. So here J is QB. So where is QB? So this A is nothing else QA. This is my QA bar. This is QB bar. So J is QA. So I've been taken from here. Okay. Sorry, I made a mistake here. So you have to draw it carefully, students. So this is in the question actually, don't worry. J is QB, is X bar, and QB. Okay, this is K. Next, JB is X bar. JB is X bar. Okay. KB is X XOR QA. JKB is X XOR QA. Where is my QA? Here. Here it is my QA. XOR Q. Okay, so this is the circuit given to me. So do you all understand what you need to do? You need to actually derive the transition table, state table, as well as state diagram for the given Murray circuit. Okay, this is the Murray circuit given to you. You can see over here, it has two flip-flops. So obviously it has two flip-flop means maximum how many states we can expect? You can expect 2 square, it is actually 4 number of states. Okay, so first of all, in step 2, if step 1, what you have to do mainly here, if this type of question is given to you, find out the state table, state diagram, as well as the transition table. So what you need to do, your solution should be, it has step 1. Actually the step 1 is determine So first of all, you have to determine the flip-flop input equation and the output equation and the circuit output equation from the given sequential circuit. Do you all understand what you need to do? Even sequential circuit. In my previous time, what you are going to do, you have been given state diagram. From there, you are designing the sequential circuit. In that case, what you are designing, you would be getting flip-flop input equation by solving KMF and output equation by solving KMF. But here, by looking into this circuit, this Murray sequential circuit, you just has to find out two things. What are those? You have to find out. You have to find out the flip-flop input equation and the circuit output equation. So what is flip-flop input equation? Flip-flop inputs are what? J, K, JB, KB. Okay, these four are flip-flop input equations, and output equation is F. These five things you have to find out. One, you have to find out here flip-flop input equations and circuit output equation. Okay, these two things you have to find out. For flip-flop input equations, you know that what are the flip-flops here? There are two flip-flops. One is A flip-flop. For A flip-flop, you have to find out J and K. For B flip-flop, you have to find out again two inputs JB and KB. Understand what you need to find out? By looking into this circuit, you need to find out two things over here. For flip-flop A, you need to find out JK. For flip-flop B, you need to find out JBKB. And what is next? You have to find out circuit output equation. That is your first step. Circuit output equation is what? F. So you need to find out F. So total 5 things you have to find out. So what is J? By looking into this circuit, you can know that J is nothing else. J is connected to QB. Okay, so I can understand here my J is QB. Okay, next, what is K? My K is what? X bar and QB. Okay, this is QB. X bar and QB. So my K is X bar and QB. By looking into the circuit, I am just finding out, nothing else. What is my JB? My JB is just X bar. Okay, my JB is just X bar. What is KB? My KB is X XOR QA. Okay, my KB is X XOR QA. It's very simple. You just have to look into the circuit and find out J, K, JB, KB flip-flop input equations. Now find out what is output equation. Output equation is QA XOR QB. Very simple. Output equation is QA XOR QB. Understand? So this is my step 1. Any doubt on step 1? Students, please let me know immediately. Did you understand step 1 or any doubt? Please let me know quickly, because this is very important. Surely one 10-mark question you can expect. Surely you'll get a 10-mark question. Yeah, tell me.
Sir, can you explain output, sir?
Output is what? Output is F. Output is F. F is what? XOR. How is XOR? QA XOR QB. Simple. Okay, so that only I have written. Circuit output equation is QA XOR QB. Understand now?
Yes, sir. Understood, sir.
Okay. Now, step number 2. What is step 2? Step 2 is very important and very difficult also. So you try to understand this carefully. Derive the transition equation. Why we have to derive the transition equation, students? Because what we need to do, we have to find out the first we have to find out the transition table. So if you have to find out the transition table, you need to know what is present state, what is next state. So for that you need to know about the how the transition has been happened. Now for that what you need to do, in order to derive the transition equation for JK flip-flop can be derived from the characteristic equation. That you need to know first. How to find out this transition equation? From the characteristic equation of the JK flip-flop. So I have used in the circuit actually JK flip-flops. So if I know my characteristic equation of the JK flip-flop, I can able to find out my transition equation. So here what you need to do, the transition equation for JK flip-flop can be derived, like this. We have to write in the exam, students, from the characteristic equation of the JK flip-flop. Understand? So first of all, you should know what is characteristic equation for JK flip-flop. You know that characteristic equation for the JK flip-flop is, we have already derived it, JQn bar plus K bar Qn. Okay, so this is my characteristic equation for the JK flip-flop. From this characteristic equation, I need to find out the transition equation. So tell me, there are how many flip-flops? There are two flip-flops. So for JK flip-flop A, I would have one transition equation. For JK flip-flop B, I would have another transition equation. Okay, for first JK flip-flop A, I am going to design my transition equation. Since it's a JK flip-flop A, I will be having QA plus 1 is actually my next state. Am I correct? So it would be nothing else, my JA QA bar plus KA bar QA. Very simple. Just I have replaced with A with, okay, because it's a flip-flop A. Okay, now what I have to do, I have to just substitute. I know my J value and K value, so I just has to substitute. I know my J is QB, K is X bar and QB. Just I need to substitute there in this characteristic equation of flip-flop, JK flip-flop A. So what you need to do here, you have to substitute JK values in equation number 2. So important, students, and difficult as well. Please try to understand. If you are not understanding, immediately ask me. J is what? QB. So my QA plus 1 is J is QB. And this QA bar is as it is. And K bar is what? K bar is, K is, I know that, X bar and QB. So I have just written X bar and QB, whole bar and QA. Okay, are you understanding? So it's very simple. So this is my, so now I have got this equation number 3 is called the transition equation of JK flip-flop A. Understand? So this is called my transition equation of JK flip-flop A. So now tell me, how the transition will happen? Mainly transition will happen from, so here I am just explaining to you how the transition will happen, students. Transition will happen from present state to next state. Okay, the present state is nothing else, my QA, next state is nothing else, my QA plus 1. How the transition will happen? If input x equals 0, there will be few transition from present state to next state, and also input x equal to 1, there will be transition from next state to present state to next state. So for that case, I need to find out actually my transition equations for x equal to 0, okay, QA plus 1 at x equal 0, as well as QA plus 1 at x equal to 1. Am I correct, students? So what I need to do, I have this equation with me, QB, QA bar or x bar. X bar means here x equal to 0. So 0 bar and QB whole bar into QA. Okay, so what I will get here, this is nothing else, my QA bar and QB. 0 bar is 1 and QB whole bar and QA. So you can come to know that here 1 AND operation with QB, what you will get, students? Anything AND operation with QB, I'll get the same actually, which is actually QA bar QB. So this is QB bar QA. Am I correct? Very simple. Okay, do you all understand this? Anything you want to do with AND operation with 1, you can see here QA and this is 1. So let's say this is 0 and 1, QA will be 0 and 1, sorry, QB will be either 0 and 1, and this is fixed 1. So what I will get here, QB and with 1, what I will get? 0 and 1, 0, 1 and 1, 1. So I am getting same QB only. Okay, that's why I have replaced 1 and QB is QB. Are you understanding? So here what I got? I have got finally QA bar QB or QB bar QA is nothing else QA XOR QB. So this is my transition equation at x equal to 0. Understand students or any doubt? Tell me. This is equation number 5. So do you all understand how I have find out for JK flip-flop A the transition equation for x equal 0. Similarly, you can find out transition equation at x equal to 1. So for that what you need to do, you just has to put at x equal to 1. So now 1 bar QB. Okay. So very simple. So QB, QA bar, and this is 1 bar means 0 into 0 and QB whole bar QA. And now you know that anything you want to make with 0 with AND gate, what it will give to me? It will just give to me 0. Are you understanding? Anything you are going to do with QB, this is 0. QB will be either 0 1, this is 0 0. What will get QB and 0 is what will get 0 0 0 1 0 0. So this is QB and 0 is you will get what 0. So are you understanding? This is QB QA bar 0 and bar is 0 0 bar. Okay, so 0 bar is what it is 1 1 and QA. So what you will get finally QA bar QB or QA. So this is my QA plus 1 at x equal to 1. So this is equation number 6. Any doubts students, please let me know. Do you all understand the transition equations, how I have find out the transition equations? I have just taken the characteristic equation, from there got the specified transition equation. After that I have know that my transition is from present state to next state. For input x equal 0 one transition, for input x equal to 1 another transition. You know that this is my Moore circuit state diagram. For if I am in this state, I am going to have for x equal 0 one transition, for x equal to 1 let's say another transition. Okay, that is the reason I have done here transition equation for x equal 0 as well as for x equal to 1. Understand? For this one is for JK flip-flop A. Now similarly same thing you are going to do for JK flip-flop B. Are you understanding or any doubt students? Please let me know. If you have any doubt, please unmute and ask me students. Parvez, did you understand?
Yes, sir.
Okay. So now we'll go for JK flip-flop B. For JK flip-flop B, again what it will be there? As we know the characteristic equation Qn plus 1, which is nothing else J Qn bar K bar Qn. So since it's flip-flop B, so I can make it QB plus 1 is JB QB bar KB bar QB. Okay. So this is my transition equation for the flip-flop B, JK flip-flop B. Now I know these values of JB, KB, I just has to put over this. So JB is what? JB is X bar, KB is what? X, X or QA. So JB is my X bar, QB. Slowly I am explaining student because it's very tough for you. Okay, newly you are understanding this one. So KB is what? X, X or QA. So X, X or QA. Whole bar QB. So I am telling if you will not understand these students, nobody will explain you again, because if you will see the book also, if you see anything you will not understand. I am saying this is very tough. You need to understand here. If you are having any doubt, you can ask me here only. Okay. So this is my transition equation for the JK flip-flop B. Okay. So this is my transition equation. This is my transition equation for JK flip-flop B. Now, as we know that my transition equation for the JK flip-flop B for x equal 0 also I have to find out. What you have to do at the time? I have to put x equal 0. 0 bar QB bar 0 XOR QA whole bar QB. Okay, do you all understand now? So here you can see 0 bar is what? 1 into QB bar. And you can know 0 XOR QA. Can it be I can write down here 0 XOR QA? Yes, I can write down, which is QB. Okay, because this is even number of inputs, so it will be, if it is even number of inputs, XOR get opposite will be my XNOR. Okay, and now what I will get here, as we know that one important concept I am going to tell you, 0, this is my QA, and what is my 0 XNOR QA? So let's say this is 0, QA is 0, and this is 0, QA is either 1. So 0 0 XNOR means what I will get? 1. 0 1 I'll get 0. So what is happening here? Whatever QA opposite, so I can write down here 0 XNOR QA is nothing else my QA bar. So it is proved here. So do you all understand this concept? Anything you can make XNOR with QA, it will be getting QA bar. So I can make it here. This is my QB bar. So this is my QA bar QB. Simple. So my QB plus 1 at x equal 0 is this one. Okay. This is equation number 8. Any doubt? Any doubt? So did you understand this? 0 XNOR with QA, you are getting opposite of QA. Here 0, it is getting 1. Here 1, it is getting 0. So that's why I can make this statement here. 0 XNOR QA is nothing else my QA bar. Okay. So that's why I have put over here 0 XNOR QA is QA bar. Okay. So I have got it for x equal 0. Now I am going to find out QB plus 1 at x equal to 1. For that case, I am going to put at x equal to 1 over here. So for that case, what I have to get? 1 bar QB bar, 1 bar and QB bar, or x XOR QA. X XOR QA means 1 XOR QA whole bar and QB. Okay. So now tell me 1 XOR QA bar. So how it will look like actually? So for that case, I can actually come to know over here, my 1 bar is nothing else 0 and QB bar, and this is 1 XOR QA. So I can write down this 1 XNOR QA simply. Yes. Okay. This is QB. And now anything AND operation with 0 is what? 0. Are you understanding? Anything if you are doing AND operation with 0, what will get simply? You will get simply 0. Okay. Or 1 XNOR QA. So I am going to do 1 XNOR QA. So 1 XNOR QA is what I am going to tell you. So this is 1, QA is either 0 or 1. So 1 XNOR 0 is 0, 1 XNOR 1 is 1. So what do you got here? Whatever 1 XNOR QA is similar to QA. So I can conclude here that 1 XNOR QA is nothing else my QA. Okay. So here I have got this is QA and QB. So finally what I got? QA and QB. So this is my QB plus 1 at x equal to 1. So this is my equation number 9. All of you understand? So these are my transition equations. What are the transition equations I have got, students? I have got 4 transition equations. So this one, okay. So I'm just summarizing here my step number 2 to you. I have got transition equation for QA plus 1 at x equal 0. I have got what? I have got here QA XOR QB. Okay. QA XOR QB. Now QA plus 1 at x equal to 1. What I have got here? I have got here at x equal to 1 QA or QA bar and QB. QA or QA bar and QB. Okay. QA bar and QB. Okay. Next, similarly, this is for flip-flop A. Similarly, for flip-flop B, what I have got? QB plus 1 at x equal 0. What I got here? I have got here QB bar or QB bar or QA bar and QB. QA bar and QB. Okay. Next, what I have got? QB plus 1 at x equal to 1. I have got it like QA and QB. So this I have derived, and this is called the transition equation of the 2 flip-flops. Okay, this is my step number 2. Do you all understand how I have find out, or any doubt? Please let me know, students. Any doubt on this? Please let me know. Students, any doubt? Himabindu, did you understand? Himabindu.
Yes, sir. Understood, sir.
Okay, good. Now, next we will go for the step number 3. Okay. What is step number 3? You need to, in the question, what is given to us? In the question given to us, derive the transition table, state table, and the state diagram. So, first in the step 3, I am going to find out now the transition table. So, step 3 is derive the transition table by looking into the transition equations. I have my transition equations ready with me. I will look into these transition equations and I am going to derive my transition table. So this is my first question over here. So it has been asked to me derive the transition table. Since I got my transition equations, I can easily find out my transition table. So first I am going to find out now my transition table as step number 3. In the transition table, tell me what are the things will be there. Any flip-flop, if I am going to find out the transition table, what are the things are there? It would have present state, next state, and the output. These 3 things will be there. Okay. Do you all understand? So here you can see my transition table would have also here present state. Okay. So, and next state. In the next state, it would be for input x equal 0, I have some next state. Input x equal to 1, I have some next state. Am I correct, students? Now, similarly, output. The output will be my f. Here, output is what? F. In this question, output is what? F. So, f is nothing else my QA XOR QB. So, I know that my output will be nothing else my QA XOR QB. So, this is my things in the transition table. Okay, what are the things will be there? And now tell me what is my present states. My present states will be nothing else QA and QB. And what are my next states? Next state will be for x equal 0, I have QA plus 1 and QB plus 1. For x equal to 1, I have QA plus 1 and QB plus 1. Okay, do you all understand, students, what I am going to do? So my input x equal 0, I would have certain next state. For input x equal to 1, I have certain next state. Okay. For now, tell me, since there are 2 flip-flops, how many states I am expecting? 2 square, 4 number of states I am expecting. What are those states? Mainly those states are either 0, 0, 0, 1, 1, 0, and 1, 1. So are you all understanding? So now, tell me, what is QA plus 1? Okay, so QA plus 1 belongs to what? First of all, A flip-flop, and I have to see x equal to 0. Tell me now, QA plus 1 at x equal 0, what is my formula? QA XOR QB. So here I can do this QA XOR QB. Am I correct, students? Or any doubt? Please let me know. Are you all understanding or any doubt on this? QA XOR QB, why I have taken? Because I know that my QA plus 1 at x equal 0 is this functionality. Now QA plus 1 at x equal to 1 is what? QA or QA bar QB. So my QA plus 1 at x equal to 1 is QA or QA bar QB. QA bar QB. Okay. Now what is QB plus 1 at x equal 0? QB bar or QA bar QB. QB bar or QA bar QB. Okay. So this is my at x equal to 0. Now tell me what is at x equal to 1? QA QB. So at x equal to 1, QB plus 1 is QA QB. Okay. Any doubt? Please let me know, students. So do you all understand or any doubt? Please let me know immediately. So here what you need to do, you have QA QB, you have all these functionalities, you just has to find out the values. What is QA plus 1? QA XOR QB. So you know that 0 0, I'll get 0, 0 1 XOR I'll get 1, 1 0 XOR I'll get 1, 1 1 XOR I'll get 0. Similarly, QB bar, QA bar, QB. So if you solve this, you'll get 1 1 1 0. So what you have to do? Take this and solve if you want QB bar or QA bar and QB. So what QB bar is 0 0 bar or QA bar is 0 bar and QB is 0. So obviously what we'll get here? 0 bar is 1 or 1 and 0 is 1 or 0. So this is 1. So I got it here 1. Understand students how I have got all these things? You have to solve this, okay, so that you will get all these values, okay, like this you have to put and solve. I am not putting because there is no time, you have to do yourself. Now QA plus 1 is QA or QA bar QB. So if you solve this also, you will get like this 0 1 1 1. Okay, how to solve this? One I am doing here QA or QA bar QB. So if you are QA, you are taking 0, so take 0. QA bar you are taking, okay, so QA bar you are taking 0 bar, okay, and QB you are taking 0. Okay, so you solve it. If you do this, 0 0 bar is 1 1 and 0 is 0 0 1. This is 0 0 or 0 0. So I have got 0 here. Are you understanding? Like this way you have to do, students. Just, are you understanding what you are going to do? This is not easy, so you need to understand each and every bit and you have to do. Next, QB plus 1. QB plus 1 is QA and QB. QA and QB means 0 0 0 0 1 0 1 0 0 1 1 1. Simple. Okay, next you need to find out outputs. QA XOR QB. So you know that XOR gets 0 XOR 0 0 0 XOR 1 1 0 1 XOR 0 1 1 XOR 1 0. Over. So this is your transition table, students. If you do this up to this, you will get 4 marks out of 10. Okay, you have find out the transition equation, then you can find out the transition table. If you do up to this, you will get 4 marks. After this, step number 4. Are you understanding or any doubt in this transition table? Please let me know, students. Aishwarya, did you understand how I have find out the transition table?
Yes, sir. Understood, sir.
It's very simple, nothing else, students. Okay, you just has to, once you find out these 4 equations, na, its life is simple. Okay, once you find out these 4 equations, life is simple. You just has to put those values and get the answers, nothing else. Okay, now step number 4. What you have to do in step number 4? Derive the state table. Derive the state table by considering the state assignment to the binary values. So I'm just going ulta, students. Are you understanding? So what is my states here? There are 4 states. What are those states? 0 0 I have taken, 0 1 I have taken, 1 0 I have taken, 1 1 I have taken. What you have to do? You have to do state assignment. For 0 0 you have to do A. For 0 1 you have to do B. For 1 0 you have to do C. For 1 1 you have to do D. Okay, so ulta I am doing. Initially I would be having A B C D. I am assigning 0 0 0 1 1 0 1 1, but here I am going through ulta process. Okay, now what you have to do after doing this, you have to derive the state table. So my state table will be, now how is it? By looking into this, you can has to do this present state, and you have next state. Okay, next state you will be having x equal 0 and x equal to 1. You have next state. Next you would be having output. Output is f. Okay, are you understanding? So present state is what? I have present state is 0 0. 0 0 means what? Just now I have given assignment to 0 0 is A. So I have just given here A. And for x equal 0, what is my thing? 0 1. 0 1 means what? B. Okay. Next, for x equal to 1, 0 0. 0 0 means A. And output is as it is 0. Okay, output is as it is 0. Understand? Very simple. Now my next state, present state is B. And for next state, for x equal to 0, I would have 1, 1. 1, 1 means D. Okay. Next, for x equal to 1, I would have 1, 0. 1, 0 means 1, 0 means C. And output is 1. Next present state is C. For that, for x equal 0, I would have 1, 1. 1, 1 means D. And for this one, 1, 0. 1, 0 means C. And output is 1. Okay. Now D. Present state is D. Okay. D means here 0, 0. 0, 0 means A. And 1, 1 means D. And output is 0. So this is my state table, initial state table. Now here you are going to check one more thing. Is there any reduction is possible? Please check it here. Is there any reduction is possible? How to check it? Any two states have same next state and output? Yes. Where? You can see here B and C. It has DC1, DC1. So 1 you can remove it. Are you understanding? Any doubt, students? So my reduced state table now, reduced state table I am going to design. Okay. So here you can see I have removed C. Means wherever C is present, I have to replace it by B. Are you understanding, students? Wherever C is present, I have to replace it by B. So my reduced state table now look like this. Any doubt, students? Please let me know. Present state. Any doubt? Immediately. Next state. X equal 0, X equal to 1. And this is my output for F. Okay. So here my present state. What are the states left out? A, B, and D. 3 states only left out. In the reduced state table, I have A, B, and D. And what is my next states? BA, DB, BA, DB, and AD. And my outputs are 0, 1, 0. 0, 1, 0. Are you understanding? So this is my reduced state table. Any doubt on this? Please let me know, students. Any doubt on this? Do you all understand how I have got the reduced state table, or any doubt? Please let me know quickly. Any doubt on this reduced state table? Aishwarya, did you understand how I have got from the state table to reduced state table?
Yes, sir. Understood, sir.
Okay, it's very simple. Next step, last step. So what we have done here, you can see in the question given to me, derive the transition table and state table and state diagram. I have already got the transition table. I have already got the state table. Now state diagram. I have to find out the state diagram only. So if you do up to this, you will get 7 marks, students. Next, for remaining 3 marks, you have to do the step number 5. What is step number 5? Please look into it. Okay, my step number 5 is here. Obtain the state diagram. Obtain the state diagram from the reduced state table. Okay, do you all understand what you need to do? You need to obtain the state diagram from this reduced state table. Okay, so from this we came to know that what I have to design actually, I have to design, this is actually Murray circuit. Murray circuit means I have 3 states. First I am going to draw that. A, next B, next C. Okay, so I would have know that it's a Murray circuit. Murray circuit state diagram looks like this. Okay, am I correct, students? Now, what are my output? For present state A, my output is 0. So I am just going to write down my output is 0. For present state B, my output is 1. For present state D, sorry, it's D. Okay, for present state D, my output is 0. Simple. Okay, now I have to do the state transition. For input x equal 0, I am now at present state A. I am now at present state A. Input x equal 0. Where I am going? I am going to B state. For input x equal 0, I am going to B state. Simple. Now, for input x equal to 1, I am in the same state A. For input x equal to 1. Understand? Now, I am in the present state B. So here I am now. Okay. Now for input x equal 0, where I am going? I am going to D. This is my for input x equal 0. Now for input x equal to 1, where I am going? I am in the same state B. This is for input x equal to 1. Now I am going in the next state, which is D. My next present state is D. I am here now. For input x equal 0, I am going to where? A. So this is x equal 0. For input x equal to 1, where I am going? Into D only. So this is my x equal to 1. Understand? This is the final state diagram, students. Any doubt on this? Please let me know. Okay. So whatever question is given to you, okay, for this, the state diagram would be this one. Okay. Do you all understand, students? If you do up to this, you'll get straightforward 10 marks. Any doubt on this, please let me know immediately. Anybody has any doubt? And do you all understand or not? Please let me know. This is very important, students. If you have not understand, ask me again. Any doubt? Quickly. IUC, did you understand? IUC. Are you there, IUC? Aksita, are you there? T. Aksita. Aksita, are you there? Hello, Aksita. S. Chaitra, are you there? T. Aksita, are you there or I'll make you out? Chaitra. Okay. Then, did you understand, Chaitra? You can unmute and speak with me. Not an issue. Chaitra. Andrews. J. Andrews. Did you understand? Okay. Did you understand, Chaitra? Please put it in the chat box. Did you understand? J. Andrews, are you there? Okay. Anyhow, I'll go for the next one. So my next question looks like this. So it actually came in the 2019 question. Okay. So this is a little bit different type. So you can see next question. A sequential circuit with two D flip-flop A, B and input X and output Y. This is 2019 question, students. 10 mark question. Output Y is specified by, you cannot get this on the book, students, because in the book they have explained very different way. You will not at all understand. That's why I'm making you understand here well. Okay, next step. And output equation. The output equations are A t plus 1 is AX or BX. A t plus 1 is AX or BX. Next, B t plus 1 is A bar X, and output equation Y is A or B X bar. Okay. So what you have to do here, the question asks, draw the logic diagram of the sequential circuit. Next bit it has been given to you. Derive the state table. Derive the state table. Next it would have been given to you. Derive the state diagram. Okay, so derive the state diagram. So do you all understand? So today is the last class for unit 3 students, and unit 4 I will start in the next week. So draw the logic diagram of the sequential circuit, derive the state table and derive the state diagram. These three things given to you. So what is given to you? This is the sequential circuit with two D flip-flops A and B, which has input X, output Y, and these are the next state equations and output equation. What you need to do? You have to draw the logic diagram, state table you have to derive, and state diagram you have to draw. Okay, so for that, first of all, you know that one important thing I am going to tell here. So these are the what you can say, like denominations for my things. A or QA is represented for the present state. Please note it down. Okay, these are the very important things. In some questions they may give A or QA. Here it is given A, means it's a present state A. Okay, now in some of the questions it may have given also for the next state. How is it given? A plus or QA plus or AT plus 1 or QA plus, like this it is given. So these are all denominations for my next step. Do you all understand? So this is my note to you. In some questions they may give this or this for present state, this or this or this or this for the next state. So here you can see AT plus 1 given as next state, BT plus 1 given for the next state. So this is for flip flop A, D flip flop A, and this is for my D flip flop B. From this question you came to know, and this is my output equation. These are the three things you came to know from these equations. Now what is given here? So I'm just doing the solution now for you. My given things over here for you, AT plus 1 is given. What is given? AX or BX. Okay, so you can know that my characteristic equation of the D flip-flop is what actually. From this we can come to know that what is my characteristic, what I have to find out. First of all, students, please tell me. I have to find out my state table. In order to find out my state table, I need to know my transition equation. If I know my transition equation, then I can say my transition is happening from present state to next state. For x equal to 0, something transition. For x equal to 1, something transition. So what I need to do mainly here, I have to do the transition equation. I need to find out, okay, for both the flip-flops. So you can see here my transition equation is given to here AT plus 1, which is next state equation. Am I correct? For this next state equation, what is it also can be written as QA plus 1, which is nothing else. A means I can write down QAX or QBX. Am I correct, students? So I can also write this QA plus 1 as X and QA or QB. Do you all understand? I have just taken X as common and I have just got my transition equation for the flip-flop A from this next state equation. Are you understanding? Very simple. Now for B flip-flop, this is for A flip-flop. For B flip-flop, my transition equation is given BT plus 1. What is given in this equation is A bar X. So A bar X it is given. So for that case, I know that my QB plus 1, this BT plus 1 is nothing else, QB plus 1. I have told you why. It may be QA plus 1 or AT plus 1. Both are similar. All are for next state equations. Okay. So my BT QB plus 1 is QA bar and X. Okay. So this is my equation number 2. For the B flip-flop, I have transition equation like this. Now, what is my output? My output is here given already, which is nothing else A plus B and X bar. Y is given in the equation A plus B and X bar. I can also write Y as like this QA or QB and X bar. Okay, this is my equation number 3, which is output equation. Okay, do you all understand, students? Very simple. Now I know that my state transition will happen from present state to next state when at x equal 0 some transition, at x equal 1 some transition. Are you understanding? For that purpose, I am going to find out for flip flop A my QA plus 1 at x equal to 0. Also, I am going to find out QA plus 1 at x equal to 1. Are you understanding? Because my state transition will happen for x equal 0 some transition to the next state, for x equal 1 some transition to the next state. Okay. So as we know from equation number 1, what is my QA plus 1? X and QA or QB. So as we know that my QA plus 1 is X or X and QA or QB. X and QA or QB. So I'm just put those things. X equal 0, 0 and QA or QB. So if I'll do anything and operation is 0, so I'll get 0. So what I got finally, I have got QA plus 1, which is transition equation at x equal 0 for A flip flop. We have got for x equal 0 is 0. Are you understanding? Now similarly, QA plus 1 at x equal to 1. What I have got actually? QA plus 1 is what actually? QA plus 1 is this one. From equation 1, I have taken this. Okay. So for this x equal to 1, I have put here QA or QB. So for 1 end with QA or QB means nothing else, QA or QB. So this is my QA plus 1 at x equal to 1. Okay, QA or QB. So this is my equation number 4. This is my equation number 5. Understand? For flip-flop A, I have derived the transition equations like this. Now for flip-flop number B. For that again QB plus 1 at x equal to 0. So before that, what is QB plus 1? I know that QB plus 1 is QA bar and x. So I know that my QB plus 1 is QA bar x. Okay, QA bar x. Am I correct, students? QA bar x. So I am going to put x equal 0 in this equation number 2. This is my equation number 2 actually. So if I put this QA bar, x is 0. So anything I will make x with 0 end operation, I will get 0. So my QB plus 1 at x equal 0 is 0 only. So this is my equation number 6. Very simple. Next QB plus 1 at x equal to 1. What you have to get? Similarly QA bar and 1. So if I do QA bar, this will be QA bar. Okay. So my QB plus 1 at x equal to 1 is QA bar. Okay, so this is my equation number 7. Understand? So I have got all the equations over here, all the transition equation for my flip-flops A and flip-flop B. Now I am going to do my state table. Okay, so in the question, what is given? You need to find out state table. Because I have got transition equation, I can easily find out now state table. Okay, so here this is my bit number 2. I am solving first. I am going for state table. Okay, for the state table, you know that there is present state. Okay, and there is, if there is present state, what are those? QA and QB. Okay, are you understanding? So because there are two flip-flops, means for flip-flop 1A output is QA, flip-flop B output is QB. So next state. For next state, what I will do? For x equal 0, I have one next state. For x equal to 1, I have one next state. Am I correct? Which is nothing else. QA plus 1 for x equal 0. QB plus 1 for x equal 0. Similarly, QA plus 1 for x equal to 1. QB plus 1 for x equal to 1. Are you understanding? Very simple. So next output. Output is my y. Here output is y. So what is output? For x equal to 0, I have different output because y output is depending upon my x. Okay, obviously output is what actually? For x equal 0, I have one output. For x equal to 1, I have another output. So what is output actually? Output y is nothing else mine. It is, what is equation of y? qa or qb and x bar. qa or qb and x bar. Okay, so here what is my present state? My present state either 0 0, 0 1, 1 0, 1 1. For that, for x equal 0, I have next state qa plus 1. Qa plus 1 is what actually? X equal 0 is always 0. That's why what I will put? I will put all zeros over here, because qa plus 1 at x equal to 0 is 0. Similarly, qb plus 1 at x equal 0 is what? 0 only. So I will put all zeros. Are you understanding, students? Very simple. Now, for x equal to 1, qa plus 1 at x equal to 1, it is just a OR gate, qa or qb, which is nothing else, qa or qb. So if I perform OR operation 0 or 0, 0, 0, 1, 1, 1, 1 or 0, 1, 1 or 1, 1, over, simple. What is qb plus 1? qb plus 1, qa bar. So qb plus 1 is qa bar. Whatever is qa, that just opposite 0 0 1 1 0 0, over. Now you can find out x equal 0, what is your output. Just put over these values. You can find out what you have to do. For x equal to 0, you will put this 0 bar. For if you put this 0 bar, what will happen? 1. So this will be qa or qb. Understand? If I put x equal to 1 over here, 1 bar is 0. So this is always 0. Are you understanding? So this is always 0. This output is always 0. You just put it here. If you have doubt, just put it here. qa or qb. X is 1 means you put 1 bar. 1 bar means 0. Anything with end with 0 means it's 0. Understand? That's why I put 0. This is just OR gate. OR gate means 0 or 0, 0, 0 or 1, 1, 1 or 0, 1, 1 or 1, 1. So this is my state table I have got. Okay. So now what you have to do? You have to do state assignment. So what is my state assignment, students? So there are how many states actually? 4 states. For 0 0, I would have A. For 0 1, I would have B. For 1 0, I would have C. For 1 1, I would have 1. That I am going to put over here to get the state table in place of A, B, C, D. Okay. So this is my present state, and this is my next state. Next state at x equal 0 something, at x equal to 1 something. Okay. Next, finally, output. Output is y. Output for x equal 0 something, for x equal to 1 something. Okay. So what are my present state? A, B, C, and D. So these are my present states, A, B, C, D. Okay. So for that case, for x equal 0, what is the 0 0? Okay, 0 0 means A. X equal to 1, 0 1. 0 1 means B. For 0 0, this is A. Next, 1 1 means D. 0 0 means A. 1 0 means C. Next, 0 0 means A. Next, 1 0 means C. Simple. Next, for outputs x equal 0, what are there? Outputs are just same as it is. It will not change. 0 1 1 0, 0 1 1 1. Okay. So don't make any mistake, students. If you do one mistake in one step, everything will be mistake. So here all zeros. So this is my state table. So now you have to check any reduction is possible. Yes, because you can see state C and state D has same next state and output. So one state can be reduced. So D can be reduced. So what is my reduced state table now? My reduced state table I can draw here. Okay. And before that, I just has to check D will be removed. So D will be replaced by C. Now you can check again. I can get any same thing, same present state. Yes, you can see in B and C, I have same present state and next state. What are those? AC 10, AC 10. So again, C can be removed. So what is my reduced state table? Final reduced state table is present state, This is my next state. And for x equal 0, for x equal to 1, output is y. For x equal 0, x equal to 1. Okay. What is my present state here? Only two states left it, A, B. Okay. So what are those present states? A, B. For x equal 0, what is my state? A. Okay. And this is also A. For x equal to 1, what are my next states? B and C. But C has been removed. So C has been removed by B. So this will be B. Okay. So B, B. Okay. Next, this is 0, 0. This is 1, 0. Okay. So this is my final state table. Okay, do you all understand, students? Any more state reduction is possible? No. For these two states, no next state and output are similar. So no further state reduction is possible. State reduction is possible. Okay, understand? So this is my final state table. Now after that, what you have to do? State diagram. State diagram. So you know that my state table here. So there are how many states? Two states, A and there is B, two states. And this is actually like this. So you can see at x equal 0, I am in same state. So x equal 0, I am in same state. So this is my 0. And what is my output? For x equal 0, my output is 0. So I have 0 by 0. Okay. Now for next x equal to 1, I am going to next state B. For x equal to 1, I am going to B. Okay. And what is output during that time? Output is 0. So this is 1 by 0. Now I am in present state B. I am here now, present state B. For x equal 0, I am going to next state A. For x equal 0, I am going to next state A. And what is my output? My output is 1. So 0 by 1. For present state B, I am now for x equal to 1, I am going to same state B. And what is my output? My output is here 0. Simple 0. So this is my state diagram. Okay. So in the question, it has been asked you to design the state table and state diagram. I have got these two bits. Okay. What I have got? I have got these two bits. This is third bit. Okay. Now first bit, the logic diagram. So we have to do final thing, the logic diagram. What to do logic diagram, students? Very simple. You know that all logic equations. What are my logic equations? I have got here. My logic equations are here. It has been given. So you can see here, like we have QA or QB and X, which is nothing else my QA plus 1. Okay. QA or QB and X. Okay. So this you will do, students, yourself. Very simple. What is there actually? You would have know that QA plus 1 is what? My QA plus 1 in the equation you can see here, which is nothing else X and QA or QB. X and QA or QB. Okay. Next. So this is nothing else my DA. Okay. And what is my DB? My DB is this one, QB plus 1, which is, what is DB? This one, QA bar X. Okay. Next, this is output Y. So you can draw this. Okay. I'm not going to do, this is your QB plus 1. I'm just write down here so that you can do yourself. QB plus 1 is nothing else. I have got actually A bar X and output Y is A plus D and X bar. Okay. So these three things given to me. So I'm going to design this. This is with the D flip flop. A, so it has DA, this is QA, QA bar, and this is D flip flop B. Okay, this is DB, this is my QB, QB bar, and here you can see this is my clock pulse, synchronous clock pulse. Okay, and DA is nothing else my what? QA or QB and X. So QA or QB and X. Okay, so this is my DA. Okay, QA, QB, X, and QB plus 1 is A bar. A bar means QA bar, X, and get DB. And what is my output? Y. Output Y is nothing else QA or QB and X bar. So I have taken QA, QB, OR get, and here X bar. I have taken X bar here and I have taken here for the AND gate, which is Y. So this is my logic diagram, student. Bit number 1. Understand? So this much, students, for today's class. If there is any doubt, look into my videos. If there is any doubt, you can have any doubt, you can ask me, okay, later. So is it okay? Do you all understand? Aishwarya, did you